Well, if you can find the derivative of e to the x, you should be able to work with the antiderivative of e to the x. Since the derivative of e to the x is e to the x, it is its own derivative, therefore it is its own, almost, it is its own antiderivative. So we know the derivative, if we have f is e to the x, then we know the derivative is e to the x. So that means if I take this function and find its antiderivative, that should be the same e to the x, almost. So the derivative of e to the x, it is its own derivative, it is its own antiderivative, and I'm saying almost because you need the constant of integration. So the antiderivative of e to the x is e to the x plus c. Well, if the derivative of natural log of x is 1 over x, that means the antiderivative of 1 over x should be natural log. And sure enough, that's the case. The antiderivative of 1 over x is the natural log of x plus the constant. So, those are our two antiderivative rules. The antiderivative of e to the x is e to the x plus the constant. The antiderivative of 1 over x is natural log of x plus the constant. How do we know this is correct? We know this is correct because if you take the derivative of this, you get back where you started from. The derivative of natural log of x is x. The derivative of a constant is 0. I'm sorry, the derivative of natural log of x is 1 over x. Right? The derivative of e to the x is e to the x. So those are our rules for derivative and antiderivative of e to the x and the antiderivative of 1 over x.